So we begin by graphing a quadratic in standard form. Our first move is to identify our a, b, and c values from the equation. The a is the multiplier on x squared, so in this case it's 1. B is our coefficient on just plain x, which is negative 8. And c is the constant, which in this case is 15. So our first move is to find the axis of symmetry. And that's found with the equation x equals opposite of b over 2a. So we have negative b, negative 8 for a b value. We're going to take the opposite of that over 2 times a, which is 2 times 1. So we have 8 over 2. So our axis of symmetry is the line x equals 4. And we're going to put that right onto our graph. 1, 2, 3, 4. And indicate that with a dotted line. Next, the coordinates of the vertex. Remember, the vertex is always on the axis of symmetry, so it's the y value when we substitute this x into our function. So 4 squared minus 8 times 4 plus 15. 16 minus 32 plus 15 equals negative 1. So our vertex is at the point 4, negative 1. So I'm going to plot the vertex on my graph right away. Our next move is to make a table of values. Now our axis of symmetry should be the middle value of our 5. So if I think I'm counting, starting at 4, 5, and 6 are my next two numbers. 3 and 2 come before. Now remember, if I have 0 as an x, that's a freebie because that would indicate that my c value is my y-intercept, but I don't have that given to me, so I need to plug in either 5 or 6 or 2 and 3. So let's make that happen. 2 squared minus 8 times 2 plus 15. So I have 4 minus 16 plus 15. That equals 3. So when x is 2, y is 3. Okay. I also know because of symmetry that when x is 6, y is 3. 2 units left of the axis of symmetry, 2 units right of the axis of symmetry. I also need to plug in x equals 3. So 3 squared minus 8 times 3 plus 15. So 9 minus 24 plus 15. So 9 minus 24 is negative 15 plus 15, that's 0. So when x is 3, y is 0. When x is 5, y is 0. So now I have 5 points on my grid, and I can draw a smooth curve through those points. So this is the process for graphing in standard form. Axis of symmetry using x minus negative b over 2a. Take that x value, substitute it in to the original function. That gives me a y value of my vertex. I plot that. Make a table of values, x's and y's, with my axis of symmetry as my middle number. Substitute in 2 values on the left side, and I know I'll have mirror images on the right. Let's look at graphing in vertex form. Vertex form, y equals a, which in this case is 1, times x minus h, quantity squared, plus k. The vertex is the line, is the point hk. The axis of symmetry is x equals h. So my axis of symmetry is 4. 1, 2, 3, 4. How do I know that? Because h is 4. And my plus k, I'm adding negative 1. So my vertex is the point 4, negative 1. So important to see that when it's in vertex form, your axis of symmetry and your vertex are given to you in the equation. So now we have a vertex and an axis of symmetry. Our job is to come back in and fill in our table of values. 4 is my middle number. 2 units right, 5 and 6. 2 units left, 3 and 2. So if I put 2 into this function, 2 minus 4 squared minus 1. Well, 2 minus 4 is negative 2. Squared minus 1. That's 4 minus 1 equals 3. So when x is 2, y is 3. When x is 6, y is 3. And we come back again and say, well, how about if I have 3? 3 minus 4 squared minus 1. So negative 1 squared minus 1, that's going to be 0. So I have my 5 points. I can draw a smooth curve through those points. Lastly, let's graph from intercept form. Y equals x minus 3 times x minus 5. So this is a, x minus p, x minus 5. So I have x minus 3, so my p value equals 3, x minus 5, I'm sorry, x minus q. My q value is 5. Finding the axis of symmetry. X equals p plus q divided by 2. So I take my p value and my q value. 3 plus 5 over 2. 8 divided by 2, that's 4. Axis of symmetry is the line x equals 4. I plug that in to find my vertex. So 4 minus 3 is 1. 4 minus 5 is negative 1. So that equals negative 1. My vertex is at the point 4, negative 1. I have intercepts at p, comma 0 and q, comma 0. So in this case, that's 3, 0, and 5, 0. Now I still want 2 more points here. And I can see that if I put an x equals 2 or x equals 6, it'll give me the same result. So 6 minus 3 times 6 minus 5, that gives me a value of 3. And a smooth curve. So graphing a quadratic from standard form, vertex form, or intercept form. Standard form, to find axis of symmetry, use x equals the opposite of b over 2a. Plug that value in to give you a vertex. Plot that. Make a table of values with your axis of symmetry in the middle of the 5 numbers. In vertex form, you're given the vertex hk. So let's mark our axis of symmetry, find our vertex, and then complete our table with additional points. In intercept form, we can easily find axis of symmetry and vertex once we identify p and q. The intercepts are at the point p comma 0 and x comma 0. That's where the graph crosses the x-axis. That's where y equals 0. And then we just need 2 more points. Now it's your turn. Go ahead and flip over to the second page. You'll be given an opportunity to graph an equation of function in standard form, vertex form, and intercept form.